So this is our last then film interference one. Let's do one for destructive. So here we're saying that we don't see green light with a wavelength of 521 nanometers. And we want to know what's the minimum thickness of the film. And we're told we have an oil film of N equals 1.38 on a water puddle. So we've got an oil film on a water puddle. So we have, of course, air above it. The oil film has N equals 1.38. And the water has N equals 1.33. So again, we always start off by figuring out what's the shift due to reflection. So again, let me do my blue and my green. So let's see, for the blue one, it goes from 1 to 1.38, so that's hard. So I get a lambda over 2. For the next one, I've got 1.38 to 1.33, so they're pretty similar to each other, but it is lower, so this one's going to be soft. So it's going to have a wavelength change of 0, so I'm going to get a net wavelength shift of a half. So the net shift is lambda over 2. All right, and we're told that we don't see 521. So if I have my wavelength of 521 nanometers, that's destructive. So my equation for destructive is that m plus 1/2 lambda is equal to delta L plus either the 0 or lambda over 2 due to reflection. And we know that we have a net shift of lambda over 2 from reflection. So our condition is going to be m plus 1/2 lambda is equal to delta L, which is 2Tn, plus lambda over 2. All right, so I've got, let me distribute this on this side. So I've got m lambda plus 1/2 lambda is equal to 2Tn plus 1/2 lambda. So I can actually cancel out. I've got a half lambda on each side, subtract that. So I get the m lambda equals 2Tn is the condition for destructive. All right, so let's think about what do we know? Well, we know that the wavelength that we don't see is 521 nanometers. We know the index of refraction for the film, which is oil, is 1.38. And we're trying to find T. So let's rearrange that equation first to give us T. So I'm going to divide by 2n to get T by itself. So I've got m, which is an integer, times lambda, 521 nanometers, divided by 2 times 1.38. So I've got m, which is an integer, times 188.77 nanometers. And m is an integer. M could be 0, 1, 2, 3. So actually my minimum thickness would be 0. So if there were no film there at all, but that sort of doesn't count. So let's go for m equals 1. That'll be the thinnest bit of oil that we can have. M equals 1 is going to be, thickness will be 1 times 188.77. So that's going to be 188.77. And let's see, I got 3 sig figs, so let me round that to 189 nanometers. All right, if I go to higher M's, there'll be higher thicknesses of films, and they'll all satisfy that condition that I won't see that color of green light. But the thinnest is either 0, no film at all, or 189 nanometers.